morning, everyone. My name is Vibhor, and we are back with the next session of DIGITx Bootcamp. We already have done 4 of such sessions where you learned about designing a digit service, installing digit, building a service on digit, and last session was building front end using React.js. Today we are talking about building front end using Flutter. Flutter is fairly a new technology to build front end. And to deliver this, we have Naveen J, who is a technical architect at Eager Foundation. And along with him and his team, we will go through this session around how you can build the front end UI using Flutter. So I will not take much of a time, only 2 announcements. Please use your Q&A tab on your computer for raising queries if you have it during the session. You can use chat option to interact with us. And at the end of the session, there will be a feedback form. So we request your feedback. That will help us for organizing this session and improving this session in future. Thank you, and over to you, Naveen.
Yep. So hi all, good morning. So welcome to the DIGITx Bootcamp. So today we are going to talk with respect to Flutter. So the first thing is, like, you people might know a Flutter or might not know a Flutter. So basically it's a front-end web, Android, iOS, and like multiple platforms can be like built using Flutter. So let's go through the slides. So why we choose Flutter? So basically Flutter is built in a Dart language, so which is internally used by Google, so which is ideally a TypeScript and a class based. So and the reason of choosing Flutter are multiple. So we have listed few of them here. So one is a single code base. So whenever you are creating a app or assume you are creating a web application, so you create a complete one code base, and then and you wanted to create a Android or iOS application, then you create a same code or you rewrite a code. So with Flutter, it's not like that. It's ideally a single code base. So once when you compile and build, it converts into multiple platform based code. So just for the sample purpose, as soon as I create a new application, so it creates a multiple folders such as Android, iOS, and web, and even it works with respect to multiple OSs such as Mac OS, Linux OS. So hence all the code you are writing is in a single folder, so which is this lib folder. So ideally with this you will be supporting multiple platform support, and the development time is too less, so that you are not rewriting a code for multiple platforms. So you are writing one code and which is like compiled to multiple platforms. And we have a predefined set of widgets. Widgets are nothing but a component, you can say, with respect to the web technology. And we also have a native support to the APIs, which is ideally a camera or geolocation. So that will be supported by the Flutter itself. And it has a strong community base. So, and as the development effort is going less, it is cost efficient. So, and ideally you can access all the widgets, predefined widgets here. So all the widgets are accessible here, so that you can like kickstart the development just by going through these documentations. So yeah, now let's understand how Flutter works. Basically, like, you people are new, or people might not even know what Flutter is. So now let's understand how the framework of Flutter has been built to cater all these multi-platform applications, and how assume you are having a screen which is having multiple widgets or multiple icons. So how does that comes on a screen? So just before going through that, like, we will understand the architecture of Flutter. So Flutter itself is a layered architecture, so which involves in multiple layers. So the bottommost layer is called engine, so which ideally talks to a low level APIs. So where it is smart enough to interact and like display the widgets and the graphical vector graphs. So above that, we have a framework layer. So the framework layer itself is divided into multiple layers such as material, widgets, and rendering. So we will just go deeper into this today in session. And then above that, there is a application layer. So application layer is where you build applications over the framework. And now we are going through the pipelines. The full pipeline is displayed here. Let us take an example of any app. So as soon as you click on an app icon, right? So there might be, that is ideally taken as a user input, and above that there might be some animations which will be going on. So and so on tapping of it, there might be building of certain screens, or like it might be opening a pop-up or a button. So that is ideally called as a build. So it internally includes certain phases such as layouting, painting, composition, and the rasterizing is nothing but so conversion of lowest level pixels on your screen. So whatever you have created, right? So ideally at the end of the day, in your phone, you will be seeing that as a pixels. So that is converted with the rasterizing. So yeah, so the layouting, painting, and composition is ideally called as a phase of rendering. So where whatever you are seeing on a screen, on a phone, so that includes internally, these phases will be happening internally. So to a overview, like you cannot, so these are the technical terms. To explain it, like assume you are having a vehicle, the moment of vehicle is at the end you are achieving. So to that internally, there might be certain cycles or certain wheels might be like rotating, right? So those wheels rotating are the phases, so which is like displayed it here. Any questions or any doubts? So let us determine what layout is. So layout is nothing but assume you are having any component on a screen. So to display that component on a screen, there might be like we need to ideally define the size of that component and where that component needs to like rendered on a screen. So that is nothing but a position. So to display that, ideally we have a certain constraints we followed. So whenever a component gets created, so to display that component on a screen, it passes a constraints. So which is ideally we have having some technical term called as render object and a render box. So to that, ideally we have multiple constraints such as minimum height, maximum width, or minimum height, maximum height, and the minimum width in height out or height in width out constraints. So let us now, as we all got to know that, like we have a component, and we ideally the displaying of a component is nothing but a layouting, and to layouting we ideally want to calculate the size and position of a widget. So yeah, just before going for the calculation, let us ideally like define in the layouting, we have two types of widgets. One is inflexible widget and other one is flexible widget. What does these two differs is inflexible widgets are something which you define specific size. So where assume you have a specific box, so which has a width and height specified, and the flexible widgets are something which occupies the size of a parent. So for example, let us take an example of text box. So which is an inflexible widget. So which ideally you need to define a specified size. If you or not, if you are defining a more size, then it automatically overflows. So that is what inflexible widget is. Going to the practical of that. So I'll just showcase that how inflexible widget is and how does it affect the screen. So as of now, I'm running a Flutter application. So if you just see the screen, so the text box itself was a inflexible widget where you wanted to define a specified size. And if the size is over the maximum size, so it doesn't even wrap it and it comes on a next screen. So it automatically, like it doesn't wrap it, it cuts off or it overflows on the screen. So that is nothing but a inflexible widget which you are talking about. And if you wanted a flexible widgets, right? Flexible widgets are something which automatically like converts the screen, which takes and which wraps to the screen with the constraints. The constraints which I showcased earlier was this: the maximum height or maximum width, or mean height and max height, or the mean or width in height out. So width in height out is nothing but you have a complete box, so which you had defined a specific width, but you didn't define a height. So for that, what happens, it takes a certain width, and whatever the text you enter on that, it automatically like wraps it, and the height automatically adjusts on the whatever the width you are provided. So if you want to go that on practical, let us have a, so here I've specified a height. So in that case, let me just specify a width. So for this, it's a height in width out criteria. I'll just wrapping this with the text. Whatever the text I've added, I'm be taking that itself. Yep. So earlier, whatever the text you saw, that was completely overflowing on a screen. But this is a flexible widget, so which is ideally like wrapping the text with a specified height and a specified width and height. So that is where your text will be like wrapping inside a widget. So hence we will like, this is a how the flexible widget works. So yeah, so for the sample purpose, we are going with a layout flexible widget. So with this, ideally we are including both a flexible widget and a inflexible widget. So which is ideally I'm taking a 3 components. Okay, basically I'm taking a 3 components. These two are flexible widgets, and this one is an inflexible widget. So to this, if you want to render or like right now, the aim is to calculate the positions and the size of these widgets so that it renders on a screen. So the first thing is how this layouting works is it ideally extracts the inflexible widgets first, so that it want inflexible widgets are something where you want to define a specific size. So for this, whatever you are seeing this is a container widget, so which I've taken up. So whatever the maximum height we are given is the incoming height. So that is nothing but we have given a height of it's a width of 100. So let us calculate. So with this, ideally we will get the maximum height and the maximum width, whatever given was 100. So to get the computing space, that is nothing but you have a inflexible widget and you got a specific width and height of that widget. Now you want to calculate the so inflexible widgets are nothing but you have a specified width and height. So you got that width and height, that is nothing but a size. And now you are calculating what is the free space available on the screen, so that I can allocate some spaces for the flexible widgets, that is auto expandable or auto compressible widgets. So for that, we have a formula where ideally overall width is equal to incoming maximum width. So the overall width is nothing but your device screen width. So that is this. So we can ideally calculate that with the help of a key. So yep. So I just printed a media query, and with that, ideally I'm getting a context.size.width, which ideally gives me a complete width of a screen. Yep. So now it specifies that the overall width of a screen is 430 pixel, I mean the 430 frames. And the free space will be calculated with the help of overall width minus sum of width of inflexible children's. Now let us calculate the width of inflexible children's. That is, ideally we have given an input of that is 100. So the formula for that, with the help of that formula, so the overall width was 330. Just to reconfirm it. No, it's 430. 430 minus the sum of inflexible widgets. The sum of inflexible widget was 110, because we are having only one inflexible widget whose width is defined as 130. So whose width is defined as 100. So minus 100. So according to the formula, the free space which is available is 330. And after that, we want to calculate the space per flux. So that is ideally free space divided by sum of flux factor of flexible children's. So the flux factor of flexible children's are defined here. So it is 1 and 2. Is nothing but sum of flexible factor, in the sense it's we are having 2 plus 1 is 3. That is 330 divided by 3. So now the space factor we got is 110. Yeah, so with that, we have right now having a space factor of a specific widget, right? So now let's calculate the layouting of a flexible widget. How does layouting of flexible widget happens? Now you are right now able to identify the size of a inflexible widget, and you already got the flux factor. Now let us calculate the width or the height of whatever the width it should take on a screen with the help of the formula, that is a flux factor into space factor. The flux factor was 1 into the space factor of this is ideally 110, because 1 into 110 is 110. So let us just verify that whether it is taking the width of 110 or not. So that is the first screen. So let us add a key here. Even. And for the temporary purpose, I've added a button so that which ideally gives me a width of whatever it is taking. So let's do a 1 round of preload. Yep. So it is taking a 110 of width. So for this, you got the width, and for this, you got a width. So now let's calculate the width for this. So according to the formula, it will be like the flux factor into the space factor. That is nothing but the flux factor you got was 110, and the space factor you're having is 110 into 2. That is nothing but 220. So according to the formula, this widget should take a width of 220. So let us just verify that. Yep. So it is taking a width of 220. So now right now you got a widget position. I mean the width of a specific widget, whatever the width it is taking, we have calculated all of them. The overall width was this, and each widget was taking this width. So now let us calculate the position of a widget. So right now you got a size, how much it is taking. So now let us calculate the position, what it is taking. To calculate the position means nothing but the width and height. So which it is given in the formula as whatever the overall width is, whatever the width you are given by the screen. So that is nothing but your screen's width, which is 430. And the overall height is a maximum height of children's and the incoming minimum height. So the maximum height of children's is nothing but whatever the max height which is given with the screen, and the minimum of height of widget, child widget. So the inflexible children's height, whatever the minimum height is 100 and the maximum height is 120. So hence max of 120 and 100 is 120 itself. So hence this row is taking a height of 120. So let's verify that also. So is not instead of width, we'll be calculating the height. Yep, you are just verified that the height is 120. So by this formula, ideally all your components, either it's a button, either it's a input field, every widget will be rendered on the screen based on this formula, so that it is fast compared to other frameworks. Any questions or any doubts?
Folks, if you have any questions, you can always use Q&A tab. So far we don't see any Q&A, so go ahead.
Sure. So yeah, right now you got the size and the position of a specific widget. So now you wanted to paint on a screen. So how does the painting happens? So earlier with the widgets, which it is, the order was different. First it calculated the size and position of a inflexible widgets, and then it went for flexible widget. But in the painting, the order itself is different. It ideally does a BFS, that is a breadth first search, sorry, depth first search, and then it ideally takes each and one element and it paints, and next it checks for the, as soon as it completes the painting, and then it checks that whether do you want to paint other screen or not, other widget. So if it wants to paint that, then it goes to the next node and it paints, and then it comes back. Like that is how the painting works. And the compositing is nothing but this ideally makes a game changer for the Flutter. So assume you are using a phone and you are scrolling the specific widgets in the sense you are, whatever you are viewing on a screen itself is a widget. So how this Flutter is faster means, so it doesn't even like does a painting and layouting for every widget. So as soon whatever you're seeing on a screen, that will be like painted and rendered once. So post that, it ideally it doesn't even touch each and every widget to repaint that. So what it does is it ideally just moves a position, that is the offset. So whatever the position of that specific widget was there, it just does a movement of that position of widget, and whatever the component which was supposed to be added, so that is only that component or that widget gets layouted and painted. So hence this will be this is ideally a game changer, and this is how the Flutter is a bit faster. And at the end, whatever the it ideally, it's a magic number which Flutter takes. It takes a 3 widgets as a number. So whatever the 3 numbers which is having, so that is only the composition which is happening. Post that one other component gets painted, layouted, and attached to the widget list, and then post that the above one will be like removed off. So hence this is how the Flutter composition layer thing works. So yeah, basically like right now, whatever you are seeing is just how it works. So let us just go deeper into what is what are the pre-components of Flutter, and how do you create a components, and what are the built-in components which will be available on a Flutter. So basically Flutter uses a same tree DOM structure, which is being utilized in the any web application. But only thing it differs is it's works on a engine called Scala, which is a canvas based application for web applications, and it ideally converts into a native code once when you build the code. So yeah, basically as it's similar to your Spring Boot or a Java application which has a main method, that is our main app. So then it has a material which is a layered one. Oh, sorry. Yep. And post that there are the screens and on a page. So page is nothing but a scaffold. We ideally define that as a technical keyword called scaffold. So and the post that there's an app bar. App bar is nothing but whatever you're seeing on a screen, right? So this one, the above purple colored one, where I defined that Flutter demo homepage. So that is ideally defined as app bar. So and the the complete screen which you're seeing, the white colored background. So that is nothing but your scaffold. So, and the center columns are nothing but a specific widgets where you want to define certain things. Column is nothing but if you want to display a components one after the other. So with that, ideally we will use a widget called column. So that is a predefined components which is given by the Flutter, so that the development effort will be faster and quick, so that you don't need to build everything and from scratch. Most of the components are optimized and built by them. So we will be ideally using them so that you don't need to like put an effort while creating these components. So these are the predefined components which is given by the Flutter itself. And the floating action button, which you are seeing this, whatever you're seeing this was a floating action button. And the icons, so the post icons is once when you open an app, so with that ideally you get an icons, and we have icons library which is utilized by the material UI. So it is following the same standards. And then the text, whatever the text which I showed here, so this, so which is again a text widget, so which can be defined it here, the text widget. Yeah, I think these are the basic building blocks which are using to build any screen. So yeah, now let us like, since from the session started, I was talking with respect to widgets. So what does these basic widgets are? Widgets are nothing but the least pixel you are defining. So basically widgets will have two types. One is a stateless widget and the one is a stateful widget. So the stateless is nothing but it is immutable and the properties cannot be changed. Assume you have a certain screen and that screen's data is coming from somewhere else. So, and you are not doing any change on that. So with that, ideally we use a stateless widget. So basically why we use this is for the optimal performance point. So every time when the engine checks, so it ideally differs from stateful and stateless, and it maps to the re-rendering phases, so that the stateless widgets are performed very high with respect to stateless, and the components does not have a state management for that specific screen or a widget itself. So with respect to stateful, where you are maintaining a state on that specific screen, so the re-rendering will happen on that screen itself. Yep. So any questions, or we will just deep dive into the code and let us build a one form.
I think let's go ahead.
Yep. So basically, like the prerequisites is you want to have a Flutter set up in your local machine, and you like to create up any, as soon as you set up all the applications or the frameworks in your system, you can create a project with a command called flutter create and the project name. So let us do that. Okay, so ideally, as soon as you install a Flutter, we need to check the version and all. We have a command called which specifies the command, what is the Flutter version you are using, and what is the engine version, and what is the framework version, which I told in the earlier. We have a like layered architecture of engine, framework, and the application. So that is what it specifies here. And yeah, so let us create a application now. Create, let's call as form. It takes a while and it creates all the specified components here. So now it also says how to run a specific application. So let us open the code. Yep. So as I told earlier, so as soon as you create a Flutter application, so it creates a multiple folders for the multiple platforms. So Android, iOS, Linux, Mac, web. So yeah. So let's go and let's ideally like run the application. What does it give? CD plus home and ls. It's nothing as such. So now I just want to run the Flutter application on my emulator, which is here. So right now it ideally launches on the application which you're having. So assume to run on emulator, you want to run the emulator first. So or else if you want to run the application on a web. So yeah, let this complete and then we'll just run the same code in the web and we can just showcase how this works on web also. As of now, when you create a application by the command of Flutter, so it generates certain screens for sample running purpose, which has all these details here, where it is having an app bar, background color, title, and the column, which I told earlier, and which is having again a text and the normal. It is creating a stateful widget, so which you can see the first screen, whatever you're seeing app is a stateless, and this home page is a stateful widget. Yep, it is building in the next code. Like probably this will take some time for the first time because it needs to compile and send the code to the emulator. And the later we have a hot reload. So just by pressing one button or one key press, it ideally like refresh the screens. Yep. So you are able to like see all the whatever the component or a screen which is created by the Flutter, which is a stateful widget. So hence it is maintaining a state on the screen itself. Only that specific widget is re-rendering. So yeah, so now let us run the same code in an emulator. So in a web. So as of now, I'll just close the emulator. So by default, if you are not connected to any emulators, it runs on a web. So it asks for whether do you want to run the application on a Mac OS or a Chrome. So I'm just going with the Chrome. So for web, you are not doing any specific coding separately. So you are having a single code base which is compiling and which is like deploying the bytecodes or a JS file on a web. So yeah, it started the same application, whatever you saw on the app, and it is same whatever you saw in the app also. Nothing is changing. So if you want to connect on that device, yep, it runs. It is basically even the responsive also. Okay. So yeah, just before going into that, so I just want to take a minute and I want to explain with respect to the digit standards or digit components which I have already built to kickstart the or to contribute to the digit platform. So basically we have a digit components which has been hosted and published in pubs.dev. So which is here. We are sharing a link in the chat so that anyone can access to that. So yeah, here we have already created the basic components required to build a form. So where it has all the prerequisite requirements such as action dialog. So if you want to have a yes or no or a pop-up, so which is ideally defined here, and we also have a checkbox which is standard to digit, so which ideally have a standard theme of digit which is by default added, or you can even customize a digit theme. And we also have a digit date picker, divider is nothing but a line which you want to, and the drop down, and the digit icon button, and the integer format picker, so which is ideally if you want to add a increment or decrement of numbers, and the outlined icon button, like basic forms fields which are required, all has been specified here. You can go ahead and you can check on that. Yep. So as of now, I'll be creating one of the form here. So let's go with the example folder and copy paste it. So yeah, I want to add that components as an import. And the reactive forms. Let's run this on an emulator. Yeah, as it is taking a time to run. So let's go through the Flutter doc. Basically, there are like all the prerequisite widgets or components which is required is in the widget catalog. So where you can ideally like have a advanced UI. Even you can ideally like check on the input, how the input fields has been rendered. So it has all the components which is required for to build a specific Flutter application. And you can do a customization over that. I think this should work, right? Yeah, basically I'm just switching to this repo and just switching to that branch itself. You have new code running in your system. Done. So then let's connect it and let's showcase that. Let's stop sharing. Okay. So yeah, basically what we have done is this one, right? Okay. So what we have done is I think my system is having a version issue. So let us just check the specific things which I have done. So basically we have added a digit components and a reactive forms. Let us just add that. So what are we used is we have directly like utilized a package of digit components and the reactive forms, which is dependency of digit component. So on the main screen, we have created a keys, so which is nothing but a controllers, you can say. So in the scaffold, we have used the reactive forms, so which is ideally a form screen where you ideally capture the details of a specific field. So this is a digit text form field, so which is having a label, form control key, whether it is required or not. And if there are validations, we can add a validations of this. But if it is required, what should be the error message you should show? If it is a min length, what should be the message? Max length, what should be the message? And we also have that reactive form, so where we are having a drop down. and the same text. And even the text is also having a the type, whether you need to display it as a number keypad or whether it should be a text, the normal QWERTY keypad. And this for the drop downs. Screen share is not happening. Oh, sorry. So, yep, this is what I was talking about earlier. So these are the key names where you, if you want to have a like data dot value. So for that, we are having that key name so that whatever the values which is captured in the form that is being extracted with this key. And so these keys are mapped to a form controls. And whether it's a required field or not required field, that has been defined here. So where we have a is required true and it has a validation messages. So whether if it is required and if user doesn't enter that, what should be the validation message to be displayed, and the min length, max length, and the drop down values. So whether it's a drop down, so then what should be the values which is appearing on a drop down, that can be specified here. And again, with respect to validation message, if user does not select anything, if and it's a mandatory, so what should be the message to be shown? Yep, and at the end there is a submit button which ideally captures the details. Let us just whether it runs in a system. Yes. So yep. So earlier there was an issue with